Well, we're going to take a look at isotopes, and isotopes have the same atomic number but different atomic mass due to a change in number of neutrons. So whatever the atomic number is the number of protons, which are positively charged, but when you have an isotope, it has variable numbers of neutrons associated with it. An example of this is carbon with an atomic number of 6. Well, there are 3 different isotopes of carbon. You have carbon 12, carbon 13, and carbon 14. Carbon 12 has 6 neutrons. Carbon 13 has 7, and carbon 14 has 8 neutrons. Remember, if you want the number of neutrons, you would take the atomic mass minus the atomic number. Get you the number of neutrons. So 12 minus 6 is 6, and 13 minus 6 is 7, and 14 minus 6 is 8. So that's an easy way to get the number of neutrons. Isotopes occur in varying amounts naturally, and some are more stable than others. So when we're looking at carbon 12 is a stable isotope. It means it doesn't decompose or is radioactive. Where carbon 14, which is used for a lot of determining age of previous living things, carbon 14 is unstable. Goes decay. Look at atomic mass on the periodic table. You're going to see a lot of them are, well, most of them have decimal places behind them, and that's because they take an average atomic mass. In our next video, we'll get into what an average atomic mass is. And when we start looking at isotopes, if it's an artificial isotope, meaning not occurring naturally in nature, it's made in the lab, those are radioactive, referred to as radioisotopes. So radioisotopes man-made, artificial, and they are radioactive. Probably some of the more famous isotopes we'll look at are the ones of hydrogen. So let's look at the isotopes of hydrogen. And these are all naturally occurring. Let's see if we can get a different color here. Isotopes of hydrogen. The most common one, and the one you see on the periodic table, is hydrogen with a mass of 1, and that means it only has a single proton. And you'll see its scientific name is protium, but really that doesn't get used a ton. And when you think about hydrogen, you think about the one with no neutrons, but it is referred to as protium. And it's the most common. And is stable. And has a single proton in its nucleus. So if we look at protium, the nucleus. It has one proton and it has one electron. The other more famous of the hydrogen isotopes is hydrogen. Whoops. Just bring that down. Get rid of that. Hydrogen with an atomic mass of 2. The hydrogen with the atomic mass of 2 is referred to as deuterium. An isotope, and this one's also fairly stable. And it contains single, remember hydrogen has an atomic number of 1, so it's got a single proton, and single neutron. And if you were to diagram that, which we can do here, we'll diagram this. Deuterium in the nucleus has a proton and 1 neutron. And it, again, it has atomic number 1. If it's electrically neutral, it's got 1 electron. The other famous heavy isotope of hydrogen has an atomic mass of 3, and it's referred to as tritium. This one is radioactive. And this one contains a single proton Remember, it's still the atomic number of 1, so they all have 1 proton and 1 electron. Single proton and 2 neutrons. If we were to diagram that one, we would see in the nucleus it has a single proton, but this one has 2 neutrons. And it still only has a 1 electron in its outermost shell. So that's just a brief look at isotopes. Our next couple videos will get into atomic mass units and average atomic mass. So until next time, enjoy chemistry.